To sketch this function, first I'm going to find the y-intercept. I plug in a 0 for x, and I get 0 to the 4th minus 5, 0 squared, plus 4, which comes out to 4. Of course, with polynomials in standard form now, remembering the y-intercept is just the constant term. So the y-intercept is here. Then I find the x-intercepts. That involves finding the zeros of the function. It involves solving this equation. I find zeros by factoring. To factor this, I do the thing where I do a substitution. Because this is in a quadratic form, I factor it by first factoring the corresponding quadratic. This quadratic factors into a minus 4, a minus 1. So that means the green, the fourth degree, the quartic, must turn into, well, if a is the same as x squared, then it must turn into x squared minus 4, x squared minus 1, which, you know what, that actually factors even further. Difference of squares tells me this would be x minus 2, x plus 2, x minus 1, x plus 1. So my zeros are 2, negative 2, 1, negative 1. My x-intercepts are 2, negative 2, 1, and negative 1. All of these zeros have multiplicity 1. All of them have an odd multiplicity, so I know at every x-intercept I'm going to end up crossing. Maybe I'll do this, or maybe I'll do this. It's going to be one of those. I'm definitely not bouncing, I'm crossing. Next, I sketch the end behavior. This has a positive leading coefficient. The leading coefficient is an invisible positive 1. Positive leading coefficient means this side goes up. This has a even degree, so the left side will match the right side. Since the right side went up, the left side will go up too. They have to match since it's an even degree, degree 4 even. Then I find other points if I need to. I feel like I'm pretty good. I think I could connect all these dots without finding other points. So I connect the dots, and while I'm connecting them, I pay attention to bounce versus cross. And I don't connect them with zigzags. I connect it with smooth spaghetti strand. So I start off at one end, and I go, and I go, and I go, and I hit this point. I'm just hitting all the points in order of x values. So I start with the furthest to the left, and I go work my way to the right. At this point, I know this came from a 0 with an odd multiplicity, so it crosses. And then to hit the next point, I'm going to have to turn around. And I know I could either bounce or cross here. I have to cross because negative 1 came from a 0 with an odd multiplicity. Then I go up and I reach this point. And maybe at this point I decide to turn around because I have to come down to this green point. And I know at this green point I have to cross because it came from a 0 with an odd multiplicity. I turn around, that way I can hit this point. I know I have to cross because it came from something with an odd multiplicity. And then I reach the other end. If, while I'm graphing, if I was like graphing, oh, I wonder if I bounce or cross here. I cross. There's either you bounce or cross. You bounce off the x-axis. You never bounce off the y-axis. If you did, you would have something that's not a function anymore. Let's do another. That was so fun. Let's just do another. Oh, good. This one's factored. That makes life easier. First, I find the y-intercept. That involves f of 0. So 1/2. I plug in a 0 for all the x's. It looks like I get 1/2 times negative 1 times 2 squared. So that's 1/2 times negative 1 times 4. If I multiply those together, I get negative 2. My y-intercept is at negative 2. Next, I find the x-intercepts. The x-intercepts I find by looking at the zeros. X-intercepts and zeros correspond. It looks like the zeros are 1 and negative 2. 1 has a multiplicity of 1. Negative 2 has a multiplicity of 2, multiplicity of 2, multiplicity of 1. There's an invisible 1 in the exponent. So I know multiplicity of 1 means it'll cross at 1. Multiplicity of 2 means that at negative 2, at my 0, negative 2, I'll bounce. Next, I sketch the end behavior. To figure out the end behavior, I need to know what the degree is, and I need to know what the leading coefficient is. So I'm going to not actually FOIL out f of x. I'm going to FOIL it out enough that I know what the first term is. So I'm going to think about what 1/2 times x minus 1 times x plus 2 times x plus 2 would make. I'm not actually FOILing it out. I'm just looking at what the first things are going to make. All the x's are going to make. I'm going to have 1/2 times x times x times x. That makes 1/2 x cubed. And then if I were to actually distribute, it's going to have a lot of other things, but the leading thing is 1/2 x cubed. So the fact that it has a positive leading coefficient means the right end goes up. The fact that it has an odd multiplicity means the left end isn't going to do the same thing the right is. If the right's going up, the left has to go down. If I want to find other points, I could find other points. Maybe I'll find another point just as a way of checking my own answer, making sure things are in about the right place. So maybe I know what's going on when x is negative 2 and 0 and 1. Maybe I'm wondering what happens when x is 2. So I'm going to plug 2 into the function. F of 2 is 1/2 times 2 minus 1. I'm just replacing the x with the 2. That makes 1/2 times 1 times 4 squared. So it's like 1/2 times 1 times 16. That makes 8. So I know I have the point 2, 8. Knowing that might help me graph it a little bit better. Oh, that's way off my graph. Okay, doesn't even matter. Let's try negative 1, just to be sure. Just to make sure I'm doing something not totally crazy. If I do f of negative 1, I get 1/2, negative 1 minus 1, negative 1 plus 2. Again, I'm just replacing all the x's with negative 1s. So this is 1/2 times negative 2 times 1 squared. That's going to come out to negative 1. So negative 1 will be a point. Negative 1 will be a point. Just that way, my graph's a tiny bit better. It doesn't have to be perfect. This just helps it be a tiny bit better. Now, I connect the dots. And when I connect the dots, I make sure I bounce and cross appropriately. So I start off at one end, and I work my way from left to right, hitting all the dots. So I'm going up, 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 and at negative 2, that 0 had a multiplicity of 2. It had an even multiplicity, so I need to bounce. So I bounce off of it. I hit this dot. I'm going to keep going because I'm aiming for the green dot now. Now I'm aiming for the next blue dot. 1, that 0, had an odd multiplicity. So I'm going to cross right through it. Then have the correct end behavior. Again, these graphs do not have to be perfect. If I were to throw this into a graphing calculator, it's not going to look like this. This is way not right. But it's close enough. If I were grading this on a quiz, I would just go down a list in my head, and I'd be like, okay, do they have the right x-intercepts? Yeah. At the x-intercepts, is it bouncing and crossing appropriately? Yeah. Do they have the right y-intercept? Yeah. Do they have the right end behavior? Yeah. All those things, that's a perfect score. It doesn't matter how crazy the graph is. If your graph is so crazy it has too many turning points, that's going to be some points off. But this is a plausible graph. The one I did with the rainbow pen, it's possible. So it's good enough.